Okay, factoring a sum or difference of cubes. All right, so who remembers what difference of squares is? Or sum of squares? Before we start. Nobody? Yeah, thanks, Anthony.
Like two numbers that can be square rooted, but there has to be like a subtraction in the middle.
Yeah? You're close. I'm just looking for the formula. Yeah, Gianluca?
B squared take equal B squared.
Right, that's difference of squares. Good. Okay, this is difference of squares. And sum of squares would be something like this, right? And then there was shortcuts we could do, right? Okay. So now we're going to do the same thing, but this time for cubes. Who wants to read the 3 sentences here? Jonathan, you there? You read it, Megan?
Megan has been completing her factoring homework, but she's stuck on the fourth question. She would prefer not to use the factor theorem, so she's hoping that there's a shortcut for factoring this type of polynomial.
So I actually find that this is hilarious. They've actually run out of practical situations to describe what's going on in math, so now it's just somebody doing homework. I think that's pretty hilarious, because they always try and put a blurb in here and how it like relates to real world applications. They're just like, ah, screw it, she's doing her homework. She's doing her homework, guys. That's the only time you'll ever use this is in your homework, all right? This is when you ask the question, sir, when will we ever use this? In your homework. See, obviously, textbook, in your homework. Okay, so she sees 4x squared minus 9, 16y squared minus 25, a squared minus 100. And so everything's going well for her, right? Because everything's a difference of squares. 9 is the perfect square of 3. 25 is 5. 16y squared is 4y squared. So everyone should understand what she's done, right? Everyone knows this one step that she's been able to pull off, right? If you don't understand that, this is going to be like, you know, magic to you guys if we don't at least understand difference of squares, right? That's a review. Okay? It's important though, right? That you guys understand that this is equal to that. You guys remember that, right? Yes. Okay, good, great. So now she's saying x cubed minus 27. So this set up in a similar fashion would be this. Okay? Everyone recognizes that 27 is the perfect cube of 3, right? Yeah. Okay. How can you factor a sum of cubes or a difference of cubes in one step? All right, that's what we're going to learn. So the factor the expressions ax cubed minus b cubed and ax cubed plus b cubed. Not sure why they don't put a coefficient of b in here. I don't know. Maybe we will in the next example. So using a graph to factor a difference of cubes. So we let a equals 1 and b equals 2. So we put a as 1, so just it's going to be a cubed minus b cubed, and b is 2, so we have x cubed minus 8. This is the same as x cubed minus 2 cubed. And so then they say this is the same as y equals x cubed translated 8 units down, right? Everybody understands that? Right? There's just been a vertical translation 8 units down of the parent graph x cubed, okay? The reason we're doing this is just to see what's happening, what's going on the graph. Okay, and if the graph will help us come up with a shortcut. So use transformations to graph the function. The graph shows an x-intercept, which can be used to create one factor of the polynomial. So there's our x-intercept it's talking about. And we can create a factor with that. What would the factor be?
X minus 2.
Yeah, say it again.
X minus 2.
Yeah. The only x-intercept is at 2, so x minus 2 is a factor. It was there. I didn't see it. I don't know if Jesse cheated and did. No. All right. Okay, the next thing we do is we divide the function by x minus 2 because we know x minus 2 is a factor. So we use synthesis to do that and we get a quadratic as a result. Okay? Then we use, we factor the quadratic. Oh, sorry. If x squared plus 2x plus 4 is equal to 0, then the roots are this. This is our quadratic formula. So x squared plus 2x plus 4 cannot be factored further because the corresponding equation does not have real roots. The discriminant, b squared minus 4ac, is equal to negative 12. So remember that when we have this quadratic formula and we have that value underneath the square root sign, if negative, this is again review from grade 11, if negative, then we don't have no real roots. So you can't factor it any further. So there's your expression. Okay? So far, not much of a shortcut. We're going to look at the different solutions that they give us. Solution B, using factor theorem to factor the sum of cubes. So A and B, we were giving these values. Oh, they're changing the question. A is 2 now. A was 1 before, and B was 2. Now they've changed it for whatever reason. Oh, they're doing sum of cubes. Okay. So a cubed plus 27. So we figure out that the factor is 2x plus 3 is a factor. Okay, and then we use synthesis, factor it out, and we're left with this equation. Finally, we're going to get to the way to do it using a general solution. We let a is equal to 1, so we let f at x equal to x cubed minus bx. F at b equals 0, so x minus b is a factor. We understand that from the previous lesson. We factor by synthesis. Thanks. We factor by synthesis. We're left with x squared plus bx plus b squared. And this is where we're getting close to the equation now, finally. So x cubed minus b cubed is equal to x minus b, because we know that has to be a factor. And then we're left with x squared plus bx plus b squared. So that's it. That's our nifty formula. So that's going to help us factor everything. So if b is 3, we just plug it in for b here, and we get that value. If b is 5, we plug it in and get that value. Okay, so there's the money maker. They just said different values of b. They're just making it up. All right, so let's try and use it now. Factor the expression. So remember, this is for difference. Difference of cubes. Now we have a sum of cubes. So we've rearranged it so that they're in their cube form. And we develop this equation. I'm going to kind of cut to the chase here. We'll do these two examples, but here are the formulas you need to know. Okay, there's your sum of cubes, and here's your difference of cubes. At the end of this lesson, all of those methods that we use, we're just trying to develop these formulas. Okay, and we saw a pattern, and we proved these two formulas. The important thing is that you memorize these formulas. Okay, so when you have a sum of cubes, this is how I remember it anyways. When I have a sum of cubes, the first binomial is positive. The pattern's the same, right? A, B, A, A, B, B, right? Everything is the same. It's just the signs that change. So I remember it that when it's positive, the first binomial is positive, and then the next one is negative. And then the last one is always positive. And then when it's the difference of cubes, it's negative, so it starts off negative, and then everything is positive. So positive, positive, negative, 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 positive. That's how I remember. I use this sign to dictate the sign of the binomial, and then I switch to the opposite sign for the trinomial. That's how I remember it. Okay? So however you figure it out, think of a way. Okay, so we'll go back to the examples now. factor this, first thing that we need to notice is that the x's are common. So you need to factor the x out. That leaves us with a difference of cubes. Now I can use my nifty formula to factor that difference of cubes. So x cubed minus 64, or 4 cubed, is going to be x minus 4, x squared plus 4x plus 16. Okay? And again, that's directly from here. Here. Okay? So they're just substituting those values in for a and b into this formula. A is 4. Sorry. A is x. My mistake. So a comes from here, right? The cube root of x cubed. So a is x and b is 4 because it's x cubed minus 4 cubed. So this is a and this is b. And you substitute in. And the last one, the same idea. You're going to have, oh, this one's kind of neat. It's a exponent of 9, but if you take x cubed and raise it to the power of, or to the exponent of 3, that's also a perfect cube. Okay, so you can have that situation. If you see something like that, 9 times or 10 times out of 10, it's going to be a shortcut answer. Okay, because, really we don't have any method to solve, or it'd be extremely difficult to use factor theorem with an exponent of 9, right, a degree of 9. So there's going to be some sort of shortcut there. So again, they find out that x cubed is just a, and b is 8, and they substitute into the formula down here. The reason why this is important and when it's going to come up is because you're going to use factor theorem, and you're going to end up with something like this or something like this. And if you don't know how to use this formula, if you don't remember this formula, you're going to be stuck here. And you won't be able to solve for the respected zeros. Okay? Any questions with that lesson? Very short. Still equally important though.